All right, IBSL1, happy Thursday. We are back talking more and more about sequences today. Today we're going to finish off 1.2. I wanted to do a couple examples for you guys of some basic geometric sequences. Yeah, so let's get started. This first one, find the common ratio and u sub 9. So we're going to find the ninth term of this. You guys, some people can spot the common ratio between stuff like this pretty easily, and other people, like, you might be just stare at it and not know what it is. So I want to talk about the trick about how you can always find the common ratio of a geometric sequence, which is take any term on the right and divide it by the term on the left, and this should be the common ratio. So if you take -1/4 over 1/2, this is the same thing as -1/4 times the denominator upside down, that multi-flip where you take the denominator, bring it up top and multiply, but upside down, and then the 2 and the 4 cancel each other out, leaving you with 2, so this is -1/2. That is your common ratio for this problem. That should work between any two terms, not just the first two terms. So if you were to take 1/8 and divide it by -1/4, you would also get -1/2. So the general term for a geometric sequence is u sub 1 times r to the n minus 1. So this particular sequence is, the first term is 1/2, and it's being multiplied by -1/2 to the n minus 1. Now that I have the general term for this sequence, I can find any term in the sequence just by plugging in the different n values. So if I want to find the ninth term, u sub 9, it's first term times the common ratio to the power of 9 minus 1. So this is 1/2 times -1/2 to the 8th power. Then, let's see, -1 to the 8th is just +1. So really it's like 1/2 times 1 over 2 to the 8th, which is the same thing as 1 over 2 to the 9th. And then, I don't know 2 to the 9th offhand, but we'll see. It's 512. So u sub 9 is equal to 1 over 512. Next problem. Find the 8th term of this sequence. Well, you have to be able to spot the common ratio of how you turn a 7x into a 14x squared. Some people might just look at that and see that it's being multiplied by 2x every single time. What is going on? 7, 14, 21. Make sure I wrote it down right. Well, from 7 to 14 it doubles, but then from 14 to 21 it's like 7 times 3. Wait, so it gets multiplied by 2. It's like being added by 7. I think they made a mistake here. Let me look in the book real quick. They think it's going up by 2x each time. Well, if it is going up by 2x each time, they goofed this term right here. So, classic our book, I think that they messed that up, that this should have been, 28x cubed, not 21. Otherwise, it doesn't work. So, you guys, if you don't know the common ratio, take term on the right, divide it by term on the left. That means r is equal to 14x squared over 7x. Then the 7 over 14 can be reduced, and the x squared over x can be reduced, so this is 2x. So the general term is the first term times the common ratio to the power of n minus 1. So if I want to find the 8th term, I just have to replace n with 8. So 7x times 2x to the 7th. Now remember that if you are going to do 2x to the 7th, that the 7th has to go to the 2 and to the x. So this becomes 7x times 2 to the 7th times x to the 7th. So then 7 times 2 to the 7th is 896. So we get 896x to the 8th. Next problem. Given the first term is 81 and the sixth term is 1 over 729, find u sub 2, u sub 3, u sub 4, u sub 5, so that the sequence is geometric. So geometric means it's being multiplied by something every single time. So you don't always have to do this, but sometimes it really helps me to kind of draw out the sequence that it's like 81, then the second term, the third term, the fourth term, the fifth term, and then the sixth term is 1 over 729, and then it keeps going, ... So our job is to find second, where's my highlighter? Oh, second, third, fourth, and fifth terms in this sequence. You could guess and check your way through this, or you could try to start using the equation. The equation is that we know the first term is 81, so it's like u sub n equals 81 times r to the n minus 1. But we don't know what the common ratio is. Once again, you could kind of guess and check it, but I like to do a more algebraic version. We know that the sixth term is 1 over 729. So that means I can replace this part with 1 over 729, and then replace this part with 6, because that's the sixth term. So 1 over 729 is equal to 81 times r to the 6 minus 1. Now, to be able to solve this, what do we want to do? I would divide both sides by 81 to get rid of this 81. So divide this, that goes away. But then dividing by 81 is the same thing as multiplying by 1 over 81. And then 81 times 729 is 59,049. So this is 1 over 59049. And then this equals r to the fifth. Now, to get rid of r to the fifth, you have to do a fifth root. But how do you do a fifth root on a calculator, Mr. Jelly? Well, you don't actually do a fifth root button. What you do is you raise that entire side to the 1/5 power. Remember, like if you raise something to the 1/2 power, that's the same thing as square rooting. So you can raise this to the 1/5 to figure out what it is. 9 to the 5th power, or sorry, 1/9 is r. So let's see. I found the common ratio. We're not done. We just know that the common ratio is 1 over 9. So that means between each of these terms that I would have to multiply by, hold on. I'm going to multiply by 1 over 9 each time. So 81 times 1 over 9 is 9. Multiply that by 1 over 9 again, you get 1. Multiply by 1 over 9 again, and you get 1/9. Then 1 over 81. And then I assume 81 times 9 is 729. So there's our terms. I guess I could write it out formally. U sub 2 equals 9. U sub 3 equals 1. U sub 4 equals 1/9. And U sub 5 is equal to 1 over 81. That's a horrible box, Charlie. Come on. Cool. Interesting problem. I think it really helps to draw it out like this visually, for me at least. Don't always have to do it. Next problem, geometric sequence. The first term is 5, the fifth term is 1280, and the last term is 20480. Find the number of terms in the sequence. Well, similar to the last problem, I'm just going to do a quick, draw it out that the first term is 5, second term, third term, fourth term, and then the fifth term is 1280, and then we have to go all the way up to whatever this 20480 is, but we don't know the term number. So the goal here is what the n value is going to produce that 20,480. Well, the formula so far is first term times r to the n minus 1. But we don't know what the r value is. But we do know that the fifth term is 1280. So I can replace this with 1280 and this with 5. So I'll do it here. Divide both sides by 5. So 256 is equal to r to the 4th. Then raise that to the 1/4 power. I believe it's 4. Yeah. So, take the 4th root of both sides. Similar to the last problem. So now we know our general equation is 5 times 4 to the n minus 1. This 20480 is a term in the sequence, so I'm going to replace the u sub n with that and try to solve for n. So 20480 is equal to 5 times 4 to the n minus 1. So now we have to solve for n. First thing I will do is divide both sides by 5. So 28480 divided by 5 is 4096. That number sounds familiar. I feel like it's a power. Oh, actually, it better be a power. It better be a power of 4. Okay, guys, at this point, you could use logs to solve this, but since n is probably a whole number, you can almost kind of just try powers of 4 to see which one is 4096. 4 to the 5th is not big enough. 4 to the 6th, yep. It took me 2 tries. So this means 4 to the 6th is equal to 4 to the n minus 1. Then you can drop your base and say 6 is equal to n minus 1. So that means 20480 is the 7th term. Find the number of terms in the sequence. There are 7 terms in the sequence. Next up, a car depreciates at 19% per year. A new car is $33,560. How much will it be worth after 4 years? This one's actually not that bad if you set up your geometric equation right. So, u sub n equals first term times the common ratio times n minus 1. We know that the first term is the first year that when the car is brand new, that it's worth $33,560. Now, depreciating at 19% every year. The mistake I will see from students is they will do this, which this does make it depreciate, but it doesn't make it depreciate at 19%. It makes it depreciate at 81%, because if you multiply by something by 0.19, you're keeping 19% of its value, which is not what we want. We want to lose 19% and keep 81%. Now it's good. So let's think. If you were to plug a 1 into that for the first year, oh no, hold on. It's not going to be n minus 1. I always have to kind of test these with the exponential equations and then think if I were to replace this with 0, then I would get this, because this whole part would be 1. And then at 0 years, it's brand new. It's worth $33,560. So we're all good there. We want to know how much it's going to be worth after 4 years. So 33560 times 0.81 to the 4th. It's going to be worth 14,000 and some change. Rounded appropriately. So lost over half its value in 4 years. Cool. Great investment. All right, guys. That is it for today. Tomorrow we will jump into 1.3, but we won't get all the way through it. Tomorrow we're going to talk about series. All right, guys. Good luck with your homework. Hit me up if you need any help.